Hi Bobcats, this is Miss Lee, and today's video lesson is on making predictions with ratio tables. So we've already learned how to use ratio tables to make comparisons and to find equivalent ratios, but now we're going to use ratio tables to make predictions. And we're going straight into the examples. Please make sure that you're taking good notes as we go through the examples. Okay, our first one, Joey Chestnut won a hot dog eating contest by eating 66 hot dogs in 12 minutes. If he ate at a constant rate, how many hot dogs did he eat in 2 minutes? Okay, so we're given the rate of 60 hot dogs in 12 minutes. That's our given rate, and I did not do a very good job with my rectangle there, so I'm just going to underline 66 hot dogs in 12 minutes. So setting up our tables, we are comparing hot dogs to minutes. So those are my labels. And then I write the original rate of 66 hot dogs in 12 minutes. The 66 for the hot dogs goes on the top row and the 12 minutes goes on the bottom. Now we're wanting to change. We're wanting to change the hot dogs from 12 minutes to 2 minutes. So we need to make a prediction about how many hot dogs would he eat in 2 minutes. So I've got a little question mark here showing that I want to find the number of hot dogs for 2 minutes. And this is where you use your ratio table. We've learned that there's several ways that you could do this, that you could do the ratio table. I feel like for this one, the easiest is to turn the 12 into a 2. Since we're getting smaller, we know that's division, and we would be dividing by 6. So I can do the same thing here, divide by 6, and 66 divided by 6 is 11. So the answer would be, how many hot dogs could he eat in 2 minutes? 11 hot dogs. Let's check it, and he is correct. That's a lot of hot dogs. Could you eat that many hot dogs in 2 minutes? Okay, next example. Whole milk contains about 148 calories for every 8 ounces. That's your rate, 148 calories for every 8 ounces. How many calories are in 10 ounces of whole milk? So we're wanting to change and we want to make a prediction. Instead of the 8 ounces, we want to predict how many calories are going to be in 10 ounces. So here's our ratio table. Our labels would be the milk and the calories. Our given rate is the 148 calories for 8 ounces of milk. And we're changing the milk to 10 ounces. Calories is what we want to find. Now, with the previous example, we were able to find the scale factor really easily, but we can't do it this time. We can't turn 8 into a 10. So we're going to have to do something else. One of the things you can do is see if you can simplify the 8 into a factor that is also a factor of 10. And if I were to divide 8 by 2, it would give me a 4, but 4 doesn't go evenly into 10. But I could divide 8 by 4, and that would give me a 2. So then the only question is, can I divide 148 by 4? Well, if you're not sure, off to the side of your paper, do the division. 4 goes into 14 3 times, which is 12. I have a 2 remainder, bring down the 8, and 4 goes into 8 7 times with a 0 remainder. So yes, we can go ahead and divide both by 4. Since I'm getting smaller, I'm going to go to the left. It doesn't really matter though. 8 divided by 4 is 2. 148 divided by 4 was 37 is what we found. And now I can go ahead and turn my 2 into a 10. Can use the scale factor of multiplying by 5 since I'm getting larger. Use the same scale factor over here with the 37. Multiply that by 5. If you need to do the math off to the side, do the math off to the side. 35, carry a 3, 15 plus 3 is 18. 185. So how many calories are in 10 ounces of whole milk? 185 calories. Let's check our answer. That is correct. All right, one more example. And again, we're just playing with the tables. There can be more than one way of making these predictions, of using the tables. Coach Howard cleaned pools during his summer vacation to earn extra money. He took 14 hours last week to clean 8 pools. At this rate, how many pools could he clean in 49 hours? Okay, so our rates, we're comparing the number of pools to the number of hours. The rate we're given is 14 hours to clean 8 pools. So we put that into our ratio table, 14 hours, 8 pools, and we want to predict how many pools could he clean in 49 hours. So we're changing our hours to 49. Okay, so if we want to go from 14 to 49, we're going to get larger, but 14 is not a factor of 49. There's nothing we can multiply 14 by to make 49. So we're going to have to do something different. What can we do to the 14 to help us get to the 49? If you're not sure, guys, just list your factors. What can you multiply to get 14? 1 times 14, well, that doesn't help. 2 times 7, okay? Yes, I could divide by 7 and get a 2, but then I can't turn 2 into 49. Okay, what about if I take my 7? Can I turn 7 into 49? Yes, 7 is a factor of 49. So I'm going to change my 14 into a 7, and how do we do that? By dividing by 2. Can we divide the 8 by 2? Most definitely, and we get a 4. So now that we have a 7 here as our number of hours, we can use our scale factor to turn that into 49. And we do that by multiplying by 7. Then you do the same thing here, multiply your 4 times 7, and you get 28. So your prediction of how many pools he could clean in 49 hours would be 28 pools. Check it. There we go. Whoops, sorry. 28 pools. Okay, good job, Bobcats.